Okay, we're going to look at transformations of functions, and the idea of transformations is you're doing something to your function and you're shifting the way it looks. It's going to have the same basic shape, but it's going to be shifting or stretching or something like that. So let's take our basic function here. We'll take a basic function y equals x squared. It has a graph of a parabola. It has the origin as the vertex. If I add or subtract a number to my function, what I get is a vertical shift. So here's an example where I added 2 to x squared. So I have y equals x squared plus 2. It's going to shift the function up by 2. So my vertex is here now at 0, 2 on the y-axis. If I had subtracted a number from x squared, it would have shifted it down. So that's a vertical shift. On the other hand, if I add or subtract a number to the x, to the argument, I get what's called a horizontal shift. So here's an example, y equals x plus 2. I'm adding 2 to the x plus 2 squared. That plus 2 shifts me horizontally, but it's going to shift it the opposite sign. It's going to shift it left 2. If I had subtracted a number from the x, then that would have shifted right that whatever direction, whatever number I have chosen. If I multiply the function by a number, it's going to stretch it. Or if I multiply the function by a number bigger than 1, it stretches it by that factor. So here I have a vertical stretch. I have y equals x 2x squared. So I have a vertical stretch by a factor of 2. So this function is thinner because you're stretching it vertically. Now you can also have a vertical shrink here. So here's the y equals x squared. If I put a number less than 1 in front of the x squared, in this case I put a quarter, we have what's called vertical shrink or compression. So it makes it kind of wider and it's compressed by a factor of a quarter. So it really depends what you put in front of the x squared, whether you're going to stretch it out or push it down. And it really depends. If it's bigger than 1, it stretches it. If it's less than 1, it has a vertical shrink. On the other hand, if I put a number in front of the x and then square it, like here I have 1/2 and then I x, 1/2 x, and then I square it, what's going to happen is I'm actually going to have a horizontal stretch. It's going to push it out this way. So that number in front of the x, in front of the argument, and then you apply whatever you're doing with your function, is going to stretch it out this way. And ironically, this is on purpose, if I were to perform this operation, y equals 1/2 x squared, that's the same as y equals 1/4 x squared. So that's the same graph. So you can see a vertical shrink and a horizontal stretch. They're actually the same thing. If you put a negative in front of the x, in front of the function, it's going to reflect it across the x-axis. So a negative in front of the function reflects it across the x-axis. That's what we're seeing here. So let's take an example applying a combination of these things to an arbitrary function. So suppose we're given a function here, f of x, and it has a simple function. It has 3 points, 3 vertices here. This point -2, 3, and it has a straight line to the origin, and then a line going up to the point 2, 1. So that's my function f of x. And I want to make a graph of this new function, -2 times f of x plus 1 plus 3. So we'll call this g of x. We'll call this new function g of x. But g of x is -2 times f of x plus 1 plus 3. How do I graph that based on this f of x and the points I know? So we're going to take a stepwise approach and look at this. The first thing you might want to do is look at what's happening to this function. We're going to label this. And you work inside out, just like in order of operations. I have an f of x plus 1. Well, the plus 1 to the x, I'm adding 1 to the x. What that tells me in this function is I'm going to shift it horizontally left 1. Because I'm adding 1, so I go the opposite 1. So that's going to be left 1. And I'm working inside out, so I'm going to shift the function left 1. Then this 2, what this 2 is telling me, that means I'm going to stretch it by a factor of 2, stretch it vertically. So in other words, I'm going to actually double the y values. The next thing we're going to do is we're going to look at the negative in front of this, and what does that do? A negative in front of the function is going to reflect it across the x-axis. And finally, this plus 3 is going to just shift up the function 3. So it's a vertical shift of 3. So there are 4 things we have to do to this function in order to graph the resulting what we call g of x. So let's apply all of this to these points. So I have my 3 points here, negative 2, 3, 0, 0, 2, 1 from my function half of x. I'm going to apply these operations we just said, these transformations we just said, to each of these points. So, and I'll write the resulting point in black. So negative 2, 3, if I move that left 1, that will go here. So that would now be negative 3, 3, left 1. Then I double the y value. That means a vertical stretch by a factor of 2. So I double the y value. So if I double the y value is 3. Double 3 is 6. So now I'm sitting up here at negative 3, 6. Reflect across the x-axis. So reflect across the x-axis, all that means is make this 6 negative 6. So that's going to put me down here. So now that point is going to be negative 3, negative 6. Negative 3, negative 6. And finally I go up 3. That means I move this up 3. I add 3 to the y value again. So negative 6, negative 5, negative 4, negative 3. So here's my resulting point. After all those transformations, my new point sits there, and that has coordinates negative 3, negative 3. So that's the coordinate of this first point. Now let's look at the origin. The origin is one of the points in this function. So I go left 1, so now I'm sitting here at this point here, negative 1, 0. Then I double the y value. Well, the y value is 0. Double 0 is 0. So it doesn't move, it stays there. Then you reflect it across the x-axis. Again, it's going to stay right there. And then you go up 3. So I can go up 3. I go 1, 2, 3. So my new point, the origin, becomes transformed, or sometimes we say translated, to this point here. And so this point here is the point negative 1, 3. Negative 1, 3, right there. So finally, my last point is 2, 1. 2, 1. Again, left 1. So that becomes 1, 1. Double the y value. Double 1 is 2. So that's 1, 2. Reflect across the x-axis. So instead of 1, 2, we're going to have 1, negative 2. And finally, up 3. So up 3, we're going to go back to 1, 2, 3. We're going to go back to the point 1, 1. So my resulting final point is this point right here. So now I'm going to draw this by joining the dots. And so we see here's our new function g of x, which has gone left 1. This function has gone left 1. We've doubled it, we've stretched it vertically by a factor of 2. We've reflected across the x-axis and up 3. This is my resulting g of x with new coordinates, new vertices, negative 3, negative 3, negative 1, 3, and 1, 1. So you should review this and see that you understand all these transformations that went on with the function to form the new function.